Hi, today we're going to look at some application problems for angle relationships. So if you have your notes handy, where we took notes on acute, straight, obtuse, and acute angles, plus our congruent and adjacent angle information, I'd like you to get that out now. So what I'm going to do is I'm going to share my screen. We're going to look at the first problem that has to do with angle relationships, but I want you to keep in mind that we have solved equations before. We did that first semester. And we're going to use that skill today to help us solve for X in the problem. All right, here we go. All right. So here is the first problem. So the task says, use the given information to solve for X. So if you look, here are our angles. We have angle RED and angle BLU, so angle red and blue. That's not how you spell blue though, but angle red and blue. And what we're going to do today is we're going to identify, first of all, what type of angle the pair is. Okay, so we can look at the pair and think, are they congruent or adjacent, which are right here? Or we can look at them individually and see, are they right, acute, straight, or obtuse? So take just a moment and see what you notice about those angles. All right. I know I didn't wait very long, so I apologize. So if you do want to pause, feel free. But I wanted to let you know that angle RED shows that it's acute. I can see that it's acute because it's less than 90 degrees but greater than 0. It's 23 degrees. But do you notice how this angle and this angle have that marking to show something extremely special, that these two angles are congruent? Unfortunately, they're not adjacent because they are not right next to each other. So what we're going to do is we're going to use the relationship of them being congruent and acute to help us build an equation, okay? So if these two angles are congruent or the same, then that means the two angles should equal each other. So if this angle, angle RED, is 23, then that means BLU should be 23. But did you notice how angle BLU has 4x minus 5 there for the degrees instead of 23? So what we're going to do today is we're going to figure out what X is using those relationships. So what I'm going to do is I'm going to put 23, and I'm going to set it equal to 4x minus 5. Now, if you're not sure why, again, that we did that, let me go ahead and write down really what this is. We know that the measurement of angle RED should be the same as, maybe even if you want to put that congruent symbol, should be the same as measurement of angle BLU. So I'm going to go ahead, if they are congruent, we can set them equal to each other. Now, when we solved equations before, we always identified what was on the left-hand side of the equation and the right, so we could balance it, kind of like a teeter-totter. We want to make sure it always stays balanced. So what I'm going to do is I'm going to put my line down the center of the equal sign and just right underneath the equation so I can keep my sides separate. Now, because we haven't solved equations for a while, I did put our solving steps right here on the right-hand side. So let's take a look at what we're going to do. So first of all, we need to look for where X is, and I see it here right on the right-hand side, okay? So the first thing that we're going to do is we're going to undo any or addition or a subtraction on that side. So see where it says -5? What I'm going to do is I'm going to make it a 0 pair, and I'm going to add 5 to it. Remember that if I have a -5, the only way I can remove a -5 is to add 5 to it. Think about our integer chips. If I have -5 integer chips, the only way to remove them is to have those +5 integer chips with it. And to make sure that our equation is balanced, I want to make sure that I show that I'm adding 5 on the left as well. So -5 plus 5, remember, makes our 0 pair. And 23 plus 5, if I go ahead and bring this down, this would be 28. And then I'm going to bring down that 4x. All right, the next thing that we're going to do is we're going to undo any multiplication or division. We're kind of doing the opposite of order of operations. I only see division here. I only see multiplication here. So that means I'm going to divide both sides by the number right there in front of that x. So I'm going to divide both sides by 4. Now, when I divide by 4, 4 divided by 4 is 1x. And then if I did 28 divided by 4, I would get 7. Feel free and use a calculator or a multiplication chart if you have one handy. Remember, we do have one in the front cover of our math notebook. Now, at the very end, we're supposed to check our answer. So if I got x is 7, That means when I substitute 7 into this expression, this algebraic expression, it should give me the answer of 23. So what I'm going to do is substitute it in right now. So I'm going to do 4 times 7. So instead of writing 4x, I'm going to write 4 times 7, and then I'm going to subtract 5. So 4 times 7 is 28. And if I subtract 5, sure enough, I get 23 degrees. So we know we did the right thing because these two angles are congruent, and that value of x makes angle BLU 23 just like RED. All right, let's take a look at another one. All right, so we're going to keep that same structure. I want you to look for, first of all, are the angles that are here in number 2, does it happen to be congruent, adjacent, right, acute, straight, or obtuse? Take just a moment. Feel free and pause if you like. All right, I hope you noticed this special marking right here that we talked about in our brainstorm. This right here tells us this angle is right. Not just that it knows it all and it has the right answer, but it is 90 degrees. So what this means is that if the angle is right, that means that it has to be equal to 90 degrees, okay? So when we go to set this up, this is what it looks like. Angle, the measurement of angle BEN should be equal to 90 degrees, and we have no idea right here what the value of x is, but I see an algebraic expression for BEN. So I'm going to put 2x minus 10, which is what the angle is represented by with the algebraic expression, 2x minus 10, and I'm going to set it equal to 90. All right? Now, we need to look for x again because now we have to start to solve. So my x now for this one is actually on the left-hand side. I'm going to make sure that I draw my line down the center of the equal sign and underneath so I can keep my left and my right-hand side separate. And on the left-hand side where that variable is, the next step, I'm going to undo any addition and subtraction. So do you notice how there's a minus 10? That's a negative 10. I want to get that to be a 0 or a 0 pair. So that means I'm going to add 10. If I do it on one side, I have to on the other. Remember, our goal is to always keep our equation balanced. We always want to do the same thing to both sides. So 90 plus 10 is 100. And then negative 10 plus 10, remember, makes 0. And then I'm going to bring down that 2x. The last thing that I'm going to do to solve this problem, getting closer to what x should be, is I should undo any multiplication or division. So right now I just see multiplication. 2 times x equals 100. Some of you might already know what x is. I'm going to go ahead and undo that with the inverse operation and divide by 2. 2 divided by 2 is 1x, and 100 divided by 2 is 50. All right, so we have to check our answer now. So if I'm going to check this, think about that angle BEN is a right angle. It didn't tell us that, but we saw it based on that marking. So that means whatever I substitute in for x has to make that angle equal to 90. Otherwise, it wouldn't be, it wouldn't match the diagram. Okay, so let's go ahead and set it up. I'm going to do 2 times 50. So I'm going to substitute in that 50 for x, 2 times 50, and then subtract 10. 2 times 50 is 100. And 100 minus 10, sure enough, is 90 degrees. So we got it. So what I want you to do is if you get stuck as you start to solve, and let's say you start checking your answers, you think you got what x is equal to, and you start checking and it doesn't match, make sure, again, you check in with me throughout your practice so I can help you. Okay? Okay, we have one more. So let me go ahead and scooch this down. And as we do this last one, oops, you can't see it here. Let's take a look at our angles. So we see our angles there in number 3. I want you to look to see, are they congruent? Are they adjacent? Remember, adjacent is next to. Are they right, acute, straight, or obtuse? So take a look. All right. So I know that they're not adjacent. They're not next to each other. Yes, one angle is to the left of the other, one is to the right of the other, but remember, they don't share a side. So they're not adjacent. They're not right. I do not see that angle marking. They look acute. We have no idea. They look acute. They don't look like a straight line. They don't look obtuse. So my thinking here is that they're most likely acute. Hopefully we'll find that out here at the end. But also, if you look at this marking right here, and I know sometimes it's a little tricky because it doesn't tell you, it doesn't write it out or tell you that they're congruent. But based on these markings, they're equal. Okay? So when we go to set this up, remember, if two angles are equal, the measurement of angle HIP is equal to the measurement of angle HOP. So if hip equals hop, then what we have to do is set the two algebraic expressions equal to each other. So I'm going to take the measurement for hip, which is 7x plus 3, and I'm going to set it equal to 5x plus 13, the measurement of hop. All right, now I'm going to set up my equation now with the line underneath and across so I can keep my sides separate. I don't know if you noticed, but this one is a little bit different. And I'm going to take this away just for a moment, just so I can zoom this in just a little bit closer. As I look at this, I don't know if you can see this or not, but I'm going to move my picture here. See how it says, do you see how this one is just a little bit different? I do not see a variable just on one side. I see variables on both. So I'm not sure if you remember the strategies for class, but this might be a good thing to write down. If you see variables on both sides, because that's going to happen sometimes, what we want to do is look for the smallest x term, okay? So as I look for the smallest x term, I have a 7x and a 5x. So 5x is definitely smaller. So I'm going to highlight that here. Now, if I am trying to solve this problem, what I want to do is take that 5x and make a zero pair with it. So if I had 5 x's and I want to make it 0, I need to take 5 x's away. So I'm going to show you. I'm going to do minus 5x. And this one, you have to have the x with it because we are taking away not just 5, but 5 x's. And I'm going to do the same on the left. All right. So when I do that, I'm going to make my zero pair here, but I'm going to bring down or simplify both sides. Remember, when I do that, it's going to look like the equations from example 1 and 2, okay? So I'm going to bring down my 13. I didn't do anything with this 3. And then 7x minus 5x. Well, if I have 7 of them and I take 5 away, I'm not going to just have 2. I'm going to have 2 x's left. And then I'm going to put that plus sign there because see how this 3 is positive, okay? So now I'm going to start off kind of with the steps that we were doing above. So now we're going to look for x. Right here, 2x, and I'm going to now undo any addition and subtraction that's on that side. So do you notice how this one says plus 3? So I'm going to take 3 away because I want to make a zero pair. So 13 minus 3 is 10. 3 minus 3 goes away, and then I'm going to bring down the 2x. And then I'm going to undo all my multiplication and division. Sure enough, it's another undo of multiplication. So I'm going to divide both sides to undo. 2 divided by 2 is 1, and then 10 divided by 2 is 5. So it looks like we have our value of 5, but we need to make sure now, are these two angles the same? Like, how can we figure that out? All right, so let's go ahead and check this measurement, because once we get the measurement for hip, we can find out what the measurement for hop is as well. All right, here we go. So we're going to do 7 times 5, and we're going to add 3. Okay, so 7 times 5 is 35, plus 3 is going to give me an angle measurement for hip. Measurement HIP is going to be 38 degrees. So we kind of were right. We thought it was acute, but now we have proof based on that measurement. So 38 degrees. So that means this angle has to be 2. I don't want to assume that it is. Okay, because we don't want to assume anything. We want to check it. So I'm going to put 5 inside again for x and then evaluate this algebraic expression. So I'm going to do 5 times 5 and then add 13. And again, if you're not sure of multiplication or if you want to check on a calculator, you're more than welcome to. 5 times 5 is 25. And if I add 13, guess what? this is 38 as well. So what I'm going to do is I'm going to put the measurement of angle HOP is 38 degrees as well. So therefore, we actually proved that it was congruent and we were able to check our work. So if you have an example like 3, where you end up having variables on both sides, you may not see too many of them. Just make sure, again, that you do make a zero pair with your smallest x term first. So you might want to jot that down, maybe put a little note, because some of you might not have your math notebooks with you where we had our work before. And then you can go ahead and start. Just make sure, again, that you always undo addition and subtraction first, then multiplication and division, then you're able to check your answer. So I hope all of your strategies today that you wrote down will help you in your practice this week. Just remember, if you, for some reason, have any questions about any of the problems that we're doing, please make sure you let me know, and we'll talk to you soon.